All right, you've made it this far, and what a journey you've actually had, right? You have gone ahead and created a program pretty complicated. It's actually got a lot of stuff in it. Now, this is a sequence, right? There's no conditional processing here because we're going to go more into detail on that one in chapter 6. But we have basically gone ahead and created a program with input, with some processing, and then with some output. All right, and there's some really cool stuff that's actually happened here, and I hope you've had a little bit of fun. So what's going to happen in the next, well, this chapter for sure is we're going to look a little bit closer at the identifiers in this in the code that we've been dealing with. Then we're going to talk a little bit about the variables, and I'm going to show you some kind of neat stuff, both some of the stuff that's in this textbook and some stuff that's a little bit outside of this textbook. It gets a little weird, but that's okay, right? And you'll get so much more value if you actually try this stuff out. All right. So, and we're not going to deal with anything as complicated as this. In fact, what we're going to do is we're going to bring up an empty shell, and actually before we do the empty shell, though, let me just quickly catch some of the spirit of what's going on here. So in this page, it talks about identifiers. Identifiers are basically objects that Python sort of sees. So it sees variables, those are identifiers. It sees functions, those are identifiers. We don't have any here, but there's some reserved words as well. Those are identifiers. So I would say this is a variable, that's an identifier. This is a function, that's an identifier. That's another function, that's an identifier. Anything else here that's particularly interesting? That's another function, that's an identifier. I probably think that actually, no, I'm backing off. No, that's it. And then this is a literal string. This is a literal float. And then we also have operators, all that math, and I guess the parentheses, that's all part of the operators. And what else did, and of course, then we have comments. Right, so there's a sort of nice little ecology going on there as what's going on. So we've got a lot of identifiers, and then variables are one type of identifier, and that's actually what we're going to zoom in on in the next few minutes. There are keywords, and I'm going to make a point of pointing them out as we go. We haven't used that many now, but as we start moving, for example, into controls, you've written one program that's used the word if. If is certainly a keyword. Else is certainly a keyword. Not is another keyword that we may or may not have used. While, that the book has certainly used that a few chapters ago. These are reserved words. Notice that print is not. Print is a function. But what this is basically saying is that these are words that you can't have a variable called pass, because pass is a reserved word. It's basically reserved by the language. All right, that was fun. Let's talk about data types. So far, we've been using a lot of numerical data types, and the ones I've kind of been showing off are the integers and then the floats. Those are the ones that I've been basically showing off. We've also been using strings, and we've also been using Booleans. And this is a great little thing you might want to bookmark here, or put an emoji reaction on, or whatever it's doing. Anyway, that's what you might be looking at, right? Notice, by the way, here, that's a bit of a typo because they're using Word, I guess, to create this. That's not a double quote the way that the thing will understand a double quote. All right, like that right there. That might have been a bit better, but either, it doesn't matter. The next few major lectures are going to actually be on these data types. And so for now, I'm just going to leave those alone, and we're still staying with fairly simple, or another word, which I'm just going to pull from other languages, scalar data types. Very simple data types of numbers, strings, and Booleans. So what I want to show you is I just want to show you some of the stuff that they would show you in the next few pages, but I want to kind of just sort of let you sort of see what's going on. So let's create a simple variable called age, and let's say 53. Okay, so it's a variable, age 53. Remember, in the memory of my laptop, some memory has now been reserved for Python. and some memory has been reserved in Python called age 53. So what actually is age? Is age, it's a variable, but is it a Boolean, a collection, a numerical type or string type? What actually is it? Well, there is a function out there called type. And if I basically say, hey, interpreter, what is age? It'll tell me that this guy is an integer. And it's also using the word class. Now, we're going to talk about this later, but I want you to imagine everything in Python is an object. It is an object. And what can I say about objects other than basically they are data, and sometimes the data actually has programs that it can do things on its own. But for now, forget it. Right now, just imagine you're just dealing with variables, and the word class is going to become much more interesting as we start moving down to the to basically these chapters here. So if you want to know a little bit more about it and you don't want to wait, then you might want to skim on down to there. But otherwise, you're fine. Just understand that this is basically saying that this object is of the class of integer, right? Now, imagine I basically said GPA, something that you're all interested in. And my GPA, I'm going to go 2.0 because I'm not paying attention. Now, what is the class of the GPA? That is a float. Why? It's got decimals, right? So that's a float. And that's another one of the types of numbers. I'm not going to bother doing a complex number, but that's basically what you need to know. Now, watch what happens if I go age, which we already have agreed here is an actual integer. If I go age is 53.5, in Python, it's going to do something. It's going to convert it to a float. If I go age is assigned 53, and I go, what is age? It's a string. Now, most languages aren't this flexible. You'd have to define it in advance. And I might even do a special little video on that, just so you know. But there's a reason why in our programs that I've been asking you guys to write, that I've been basically making you define your variables up front. And effectively, you've been creating this guy as a float by assigning it a float. You've been making this a float by forcing it to be a float, right? That's kind of what's going on here. You're constantly changing the data around. Now why? Now this next part I probably should have actually tried before recording this, but why not, right? There is a bunch of interesting functions that can come in if I bring in sort of a library called sys. And if I basically said, hey, sys, which obviously stands for systems, get size of the age object. That's apparently the size of the age object. That's pretty interesting. If I now said that age is 53, and then I also now say, hey, get the size of the age object. Notice it takes less size. Now, what would be interesting to me is, what if age was 53? Get the size of the age object. I want you to note that when age was an actual integer, it used less memory than when age was a string. So that's interesting right there. If I said age is 53.0, and then I said, what's the size of age? It's actually a little less than it being an integer, which actually obviously just caught me by surprise. That's very interesting. Most of your early life, you're probably not going to have to care too much about how to squeeze in make the most of your space. But I just want to remind you that this little guy here, the Voyager probe, that went right out of the solar system with a lot less memory than what's on our phones. So memory management is kind of important. And if this was a true Python class, we got a little bit more advanced, I'd say things like, you want to pay attention to what is the data type that you're working with. So watch this. I'm going to go X is assigned 5. Oops, apparently I'm not typing it. X is assigned 1 plus 2. I didn't define what X was, but it's going to assume that X is an integer, right? Now I'm going to go X is assigned X plus 1.5. So what is X now? Well, a float was allowed to come in. So now X ended up being converted to float. I can convert X back. X is assigned the integer of X. Well, actually, before I do that, by the way, what is X? Let's remember that's 4.5. So X is assigned the integer of X. What's X now? X is 4. Note what happened there, right? What happened there, your brain would have rounded that up, but when it just did a strict conversion to an integer, it lopped the change off, and it's called truncate, by the way, but basically it got rid of it because when it converted a float to an integer, it just ignored the decimals. That's very scary when that kind of stuff happens, because then you can get all sorts of mathematical inconsistencies. Let's flush this out and bring up a new shell again. All right. So let's make a real egregious one here. X is assigned 4.9, right? So what is X? X is a float, I should say. Now X is assigned the integer of X. And what is X now? X is an integer. What actually is X? That is a straight on truncate. So just, appreciate that that's a bad deal. Now, all these guys, by the way, they actually have memory. Well, they have IDs, actually. I think this is more of an ID. So if I said basically, what is the ID of X? There it is there. And boy, at one point I guess I didn't write myself a note to this, but there is a way you can try and find the actual address of it. I don't think this is so much the address, but basically here's X. It's got, just like every home's got an address, this is its address in memory, which, by the way, would look more like this, I think. Right, that right there would pretty well be what it would look like if you opened up your memory and looked at it. It would look like that. Now, I would remind you, by the way, that of course it's not that. In the hardware of it, it's going to be more like that. But of course, nobody's ever going to code with ones and zeros, at least not anymore. So I guess actually, yeah, that would be the memory address. That's the memory address of this particular ID. So somewhere in the session there, it's reserved that memory, and that's and that memory is remembering the number 4 as an integer. So what I'm going to do is I'm just going to take this, right? Actually, I'm going to copy all this into a notepad. I'm going to shut down Python. Okay, so notepad. And so all I've done here is I've just copied my little guys over to notepad. And now I'm going to shut down my Python. So I'm going to shut down you. I'm going to shut down you. And do I have anything else out here? I do have that program there. I'm going to shut down you. Shut them down. I'm going to go into my computer memory and make sure that Python is in fact gone. I don't see it up here anywhere. And I'm just going to scroll on down. Probably should reboot sometime soon, but I don't see. Oh, I do have a Python guy right there. He's running in the background, so I'm going to end him too. All right, bang. There is no more Python, no more chance of memory being knocked around. Let's go ahead and start up Python again. So I'm going to go Python idle. And this probably brought up Python itself, and then it brought up the shell. If we go and we look inside the task manager and I start looking for it, we're going to see Python right there. Don't know why I did 2. Maybe it's saying there's 2 processes, maybe. We're going to come down here. And where did I just pass it? Why do I not see Python here anywhere? Okay, well, anyway, I know it's here. It's right there. All right, so now let's quickly do a definition here. We'll go x is assigned 4. What the heck is x? And then what's the ID of x? Note it's different. Ends in 36. Here it ends in 64. It's going to become even more interesting if I just go hex, the ID of x, which is just converting that decimal number into a hexadecimal number. Again, that's the important part. I don't think I've said this enough. That isn't part of the number. That's basically just telling us this is a hex, right? And then when I went the binary of the ID of x, this is basically saying that this is binary, and by default, it's decimal. All right, but either way, that is kind of cool. I've sort of, what I've done there is I blew away my Python. I started up again. I grabbed another piece of memory, and it, of course, it's not going to go back to the same address. The entire universe of that Python instance got blown away, and now I opened up a brand new one. Just like, again, if you open up Word and you do some processing in Word, and then you shut down Word, and then the next day you open up Word again, it's not necessarily going to use the same memory. It's going to perhaps bring up another space. So what I'm probably going to do is I'm going to force you guys through a little exercise like this on your own, just so you can kind of get an idea what's actually going on in the memory of Python. But definitely, for sure, a massive take home from this is understanding that when you have a number, 4.9, remember that 4.9, that is now a float. And it remembers it's 4.9. If I convert that float, very same float, into an integer, it is going to truncate the integer. And that's a fairly common mistake some students make when they're not paying attention to data as it's being moved around. So just, I went through all the song and dance to try and break open some of your neurons so you can pay attention to the actual structure of the data that you're dealing with. All right.